All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. We are about to go over the entire air practice test, what they have released to us so far. And this is going to take a long time because I'm not only going to show you the right answers on a lot of these, I'm also going to show you, why the wrong answers are wrong. I'm going to try to walk you through every little detail of every single problem that I have. My hopes in doing this, guys, is that you would understand you would review a lot of the concepts that we've talked about over the course of this year. And as we look back at that, I hope you can either say, yeah, I remember that. Oh, I'm really glad we reviewed that. Or, man, I don't remember that at all. And I need to look at this a little bit closer. And so as we do this, I'm going to tell you right now, I'm excited. I'm excited for your opportunity with this test. We've covered more information this year than we have the past year, and last year's class did a pretty good job, and so I'm really hopeful that you guys can knock this test out of the park just like they did. So in taking a look at, the first thing I want to look at is actually the formula sheet, so you know what they're going to offer you, and that you will know the things you have to memorize, okay? Because I don't want you to assume, well, that'll be on the formula sheet when it's really not. And so as you take a look up here, excuse me, this is what they have online as the formula sheet that you guys are going to be given. And so, radians and degrees, we haven't covered any of that. That's an Algebra 2 concept. I think there was maybe one question on radians last year. I'm not worried about it. For you Algebra 2 students, I hope you're able to pick up those type of questions, but I'm not gonna spend time on it. A lot of this stuff that we see here are conversions, and so just know that you've got conversion charts there if you need them. You'll take a look there at the triangles. You've got your Pythagorean theorem here. You've got sine, cosine, and tangent. Now, I should probably just say this. You guys know sine, cosine, and tangent as so, ca, and toa. Okay, so you'll probably you want to memorize that, but if you forget it, you've got this little formula here, and let me just show you what that means. The sine of this angle, okay, the opposite side of this angle can be called BC or little a. So opposite over hypotenuse. Now the hypotenuse opposite this angle can be called little c, which is why we have a over c. Okay, opposite over hypotenuse. The cosine of angle A would be the adjacent over hypotenuse. This side right here, opposite B over here, would be considered little b. That's ABC for a squared plus b squared equals c squared. And so little b, the adjacent side over hypotenuse, you've got cosine, tangent, opposite over adjacent, a over b. So you've got it there. You just need to know how to read it. You've got your 30, 60, 90 triangle rules and your 45, 45, 90 triangle rules. Hopefully we haven't forgotten how to use those moving forward. You've got your formula sheets for your different area formulas, okay? So you've got the area of a triangle, 1/2 base times height. Now notice, little b is the base. Big B is the area of the base, and I'll get into that in a little bit. Area of a parallelogram, base times height, you're good with that. Pi r squared sounds like area to me. When I think of circumference, I think pi d, right? And so you have pi d there, or 2 pi r. Remember, it's the same formula. Goes twice the radius is the diameter, okay? Now, I don't know if we're going to get to volume this year. As I've told you in the past, I kind of left that alone because I know that you guys have covered it in the past. But when we think of volume, this capital B, if you look up above on your formula sheet, the capital B means base area or area of the base. Now, you might want to take a little quick note here that the bases of our prisms, okay, are going to be, so bases, we're going to cover this later on this year. Bases are parallel and congruent to each other. Okay, so if you have an octagonal prism, you have two octagons on both sides, you need to find the area of the base to find the volume. And so the bases were the octagons, okay? They're both parallel and congruent, hence the name octagonal prisms. They're named after the bases, the octagons. If you have a triangular prism, guess what the base is? It's the triangles. If you have, what else could I? If you have a pentagonal prism, the bases are the pentagons, okay? They're both parallel and congruent to each other. Now, the height of any prism is the distance between the bases. Okay, distance between the bases, or the distance from one base to the other. Okay, and so those, if you can figure out what those are and how to calculate the base area, and know what the distance is between the two bases, your volume formulas are very simple for the prisms. In a cylinder, what are the bases? They're the circles, so it's real simple. It's pi r squared times h, base area times height. For the sphere, you've got 4/3 pi r cubed. Now when you do this pi r, or the radius cubed, let's say the radius is 7. When you type that in, you can use your cube button to put the 3 up there, or you can use your caret button. When you do that, let's see here, 49 times 7, 343, I believe, is what you're going to get when you type in 7 to the 3rd there. And so, just something to think about. Cones and pyramids, same type of structures. They've got only one base as opposed to the two bases, the cylinder and the prisms. And so we'll talk about this later on this year, but they are 1/3 the area of the prisms and cylinders. Okay. So that's just a general overview of the formula sheet. And so now I want to actually get into the actual practice test that we have. And so if you go to my website and go to the calendar where you saw this video, you saw an actual practice test site that you can go to. If this came up, then that's good. How do you go from there, or where do you go from there? You'd want to click on this practice test down here. Okay, and that'll take you through a couple of, don't fill this out. Don't do session ID or anything like that. Just click on sign in. It's a practice test. You do need to click on what grade you're in. And so, as long as you click you're in high school, you're good to go. Okay. And then you can click yes. Okay. And here's the deal. If you want to look at these, that one right there, there's only like 3 practice problems there. It's good to know. In fact, I think last year that was part of my video that I showed kids, but it was released last year. This is the most recent one. And so I'm just going to click on that. And it's got a bunch of, I think they want to show you what the test is going to look like. Mumbo jumbo. Just click select and keep on going through, if I can. Yep. All the way to where we're ready to skip TTS check and get right into the test. Okay. So here's what we have. So this first question, let me read through it with you, and then we'll take a look at what's going on. Circle J is located in the first quadrant with center AB and a radius of S. So if I were to go ahead and graph something like this, it would look something like, okay, that right there, okay, and so the center, this ordered pair, is at A comma B with a radius of, what did it say, S? Yeah, S. Okay? And Philippe transforms. Okay, so he's going to move this in some way. Circle J to prove that it is similar to any circle centered at the origin with a radius of T. Now, similar objects have to have the same dimensions and everything, just one bigger or smaller than the other one. Otherwise, it would be congruent. And so, here's what we're going to do. We're going to move this circle back to the origin down here, okay? So how are we going to do that? How am I going to get this point back down to here? Well, this length right here is B. This length right here is A. So to go from here back to this point right here, my x value is going to have to go back A units. So I need to subtract A units to get back to the origin. And my y value is going to have to go down B units. I have to come down and over to get to that point. So the first thing I'm going to look at as I look over here is figure out which transformation is going to be correct and get rid of the ones that aren't. So this right here and this right here won't work because of the fact that we're actually getting further from the origin as we add A units and add B units. Now from there, the question then is, how do I determine the scale factor? Okay, which one is it going to be? Well, in order to prove, whenever we do the similarity ratio or the scale factor, you want to take, let's see here, you want to take where it was, the original, this is the original, over what it currently is. So, you know, this one had a radius of t, okay? We don't know if it's bigger or smaller. I'm going to claim it's bigger. But when I move this back here, and I want to know what the scale factor is, it's the original over what it now is, okay? And so as a result, I'm going to choose D right here. This would be the reciprocal. I don't want what it is over what it was. I want the original over the new circle there, okay? So I don't know if you want to make a little note of that there. Original over new figure is going to help me give the scale factor, okay? And we talked about that when we were doing similar figures probably about a month or 2 months ago, okay? Now let's go on to the next one. And this next problem actually has a lot to do with the technology. And I want to make sure that you're good with the technology portion. So as we look at this next part, it says quadrilateral BCDE is shown in the coordinate grid. Keisha reflects the figure across, the line y equals x to create B prime, C prime, D prime, and E prime. Use the connect line tool to draw quadrilateral BCDE, okay? So what I'm going to do first is let's talk about the equation y equals x. You need to remember the slope-intercept form. Okay? And so as a result, when you have a problem like this, y equals x, remember the slope-intercept form is y equals mx plus b. And remember m, that is the slope, which would be rise over run. Okay? And b is the y-intercept. Again, I apologize for the sloppiness of my pen, but it's the best I can do. So when nothing is in front of a variable, you know that that is always 1. In fact, I'll do rise over run, 1 over 1 is still 1. And when there's nothing after it for the b, you should know by now that that is a 0. Okay? So now I have to go ahead and graph that line. So what I'm going to do is I'm going to click on this right here, and I would encourage you to do this, but I know that the slope is 1 and that the y-intercept is 0. So this right here, the y-intercept is 0 and the slope is 1. So if I go up 1 over 1, up 1 over 1, up 1 over 1, it's a positive slope, okay? And you can continue to do that as far out as you like, okay? Now, you can also go in the other direction. Down 1, left 1, down 1, left 1, okay? And keep going till you get out there, okay? But that line right there has a slope of 1, y equals x. Now what we want to do is show that this figure here is reflected across that figure. So just common sense tells you it's going to end up somewhere up in here, okay? So if it doesn't, you know you've done something wrong, okay? So what I'm going to do is I'm going to take my point here and I'm going to go until I get to my line of reflection. Now remember when you're reflecting across something, it's got to be equal but in the opposite direction. So if I count this, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. That point right there is B prime. It's been reflected across. And you should be able to tell from here to here, okay, that line is perpendicular. That reflection has got to be perpendicular, okay? So if I do E, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay? If I do C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that's a lot of counting there. Whew. All right, now for D, I can count it all out, or I can just say that I know it's, well, this point right here reflected across that is going to end up being that point right there, but we can just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Whew. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Bingo, told you. All right, so from there, use the connect line tool to draw the quadrilateral B prime, E prime, C prime, and D prime. So I would still want to come back and connect these dots. And you'll notice there I'm having to click on it again. And now my answer is good. And notice here, you can double check your work. From E to B, it's rise and run up 2 over 1. Now the rise and run isn't up 2 over 1, but the distance is still the same. I have 2, 1. Okay? From B to C, I've got down 1, 1, 2, 3, 4, 5, 6. Over 1, 1, 2, 3, 4, 5, 6. So I know I've got that right. From C to D, I can go up 1, 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6. All right, and I want to get rid of that, so I'll just go delete. Click on it again. Does it delete it? Huh. Doesn't delete, does it? Oh, it did delete. Okay. Well, and again, I don't know what that point's doing there. Get out of there. All right, good. So, anyways, again, it's a pretty simple problem. My math teacher in high school always used to say, you don't need to get all the problems right. You just have to get the ones that you know how to do right. And this is one that I think most of us should know how to do. Okay? All right, let's take a look at the next one. Bada boom, bada bing. Here we go. 3 vertices of parallelogram PQRS are shown, and we have those 3 vertices. Place statements and reasons in the table to complete the proof that shows that parallelogram PQRS is a rhombus. Now, I wonder if I can make this a little smaller. Can I zoom out? No, I cannot. Maybe I can make my page a little smaller. Okay, and we're back. I was just trying to make that smaller so I could draw some things out for us here. So what we're looking at, I think the best thing to do at this point in time is probably to draw this out, because I'm going to be honest with you, I don't think the proof is very well worded here. But if I go ahead and put down the 3 vertices, okay, we've got Q, which is at 8, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Here's Q. Okay. We've got R at 5, 1. 1, 2, 3, 4, 5, up 1. And that is R. Okay. And S is at 2, 5. 2, 5. Okay, now, here's the deal. I have to figure out where point P is going to be, because that's what we're trying to figure out, that this is a rhombus. And so if I go ahead and connect these right here, these points, I want to pay close attention to the wording, my labeling, PQRS. I know right now that P cannot be down here, even though this would form a parallelogram right here. The order of the letters PQ, I can't go RS, okay? And so if I went over here, I can't go PQRS. So I know that in order for this to be a parallelogram, up in here has to be P, okay? PQRS, got it? Okay, the wording of the name is important here. And so what we're looking at is that you want to figure out, if I look down here at all these different things down here, it says the Pythagorean theorem. Well, why in the world would they have the Pythagorean theorem? Well, we've worked this quite a bit this year. The reason why we use the Pythagorean theorem is to find distance between different points in the coordinate plane. So if I want to figure out the distance from Q to R, I can do the Pythagorean theorem, and I know that this length right here is a length of 1, 2, 3, 4. And this is a length of 1, 2, 3. And automatically, all of my geometry students should start to think, oh, it's a 3, 4, 5 right triangle, okay? So as of right now, I know that QR is a length of 5. And you would take that and just put it right up in there. Oh, don't mess up on me. Try that again. Okay, it's got a highlight before it actually takes it. Now, and again, you can practice that on the website. If I do the same thing over here, okay, I want to figure out the length of SR. This length, if I count it out, 1. Oh, it's at 2. Sorry, I need to drop that down more right there. Ignore this part over here. This is at 1, 2, 3. And this will be at 1, 2, 3, 4. And so this is also a 3, 4, 5 right triangle. And so as I look at this, what I know is that QR, or I'm sorry, did I say that wrong? SR is a length of 5 as well. Okay? And I got that by doing the Pythagorean theorem. Okay? Now, since SR and QR are equal by the substitution property, we know that to be true, I can say that SR is congruent to QR by the definition of congruent line segments. I'm going to be honest, didn't make you guys really do that this year because it seems too redundant to me. But they chose to go ahead and put that in the proof, so kudos to them. And I know that PS is congruent to QR because of the properties of parallelograms. Remember that the opposite sides in a parallelogram are going to be equal in length. You might want to write that down. Opposite sides of a parallelogram have to be equal in length. Okay? Now from there, if I go ahead and PS and QR, yeah. If I go ahead and take a look at this, I know that SR is going to be congruent to PQ. Okay, so let me just make sure we understand this. If I put point P up in here, like it's supposed to be, okay, and what we've already said in our statement up here was that SR is congruent to QR. I'm sorry, PS is congruent to QR. Okay, by the property of parallelograms. I then know that SR will be congruent to PQ. So if I look here, where is SR? SR will be congruent to PQ. Okay, by definition of or properties of a parallelogram. Okay, I was going to say definition of a parallelogram, but properties of a parallelogram, which is true. Okay. From there, we know that this is going to be a rhombus because all 4 sides are going to have equal length there. Okay, so again, like I told you before, I don't think that's a very good proof. I don't think it's set up well, but that's the format that they're going to use on some of these proofs. And so you'll be expected to kind of figure it out. I really think that if you graph it off to the side and start to piece in some of the information, you're going to stumble upon the information that you need to have. Okay? So let's take a look at the next problem. All right. Trig functions, yes. All right. Here's what we know. We know that Felicia wants to draw a triangle PQR such that the conditions shown are true. The area of the figure is not 6 square units. The triangle is not 6 square units. And cosine P equals 0.6. Well, there's a couple things I would probably think through first before I start looking at this first bullet. And that's this. I know that cosine of an angle is equal to the adjacent over the hypotenuse. Okay? And so this ratio, this decimal, has the ratio of the adjacent over hypotenuse. And so what could we do here to get that? Well, I would probably convert this decimal back to a fraction. If you want to type in 0.6 into your calculator and then use your math button like we've talked about, you can get 3/5 out of that. Okay? Now from there, how does that help me figure out what this is going to be? Well, the first thing I would do in remembering trig functions is draw a right triangle. So you have to have a right triangle drawn out. So if I do that, if I draw a right triangle, the question would be, what would the side lengths have to be in that right triangle? Well, in one manner, you could go ahead and say this. If this is angle P, right here, okay, right triangle, the adjacent side is 3, the hypotenuse is 5, this is where the area of the triangle comes into play. And so here's how you have to think through this. Right now, we know that this is a 3, 4, 5 right triangle. What's the area of this triangle? Well, the area of the triangle is 1/2 base times height. 12, and half of that is 6. So what they're trying to tell you right now is you can't use the 3, 4, 5 right triangle. It's the most common one. They want you to do a different one. And so if you remember, similar triangles have sides that are proportional. So if I were to double each of these and change this from a 3 to a 6, 5 to a 10, and 4 to a 12, I would still have the cosine of angle P being 6 over 10, which is still 0.6, which reduces down to 3/5. Now, you may be asking yourself, okay, does it work with all the numbers? Well, if I were to triple that 3 and make it 9, and triple that 5 and make it 15, and triple that 4, did I make that 12? That should have been 8, sorry. Triple that 4 and make that 12. If you still take 9 is to 15, the cosine of angle P would be 9 over 15, and reduce that down, dividing that by 3, you would get 3/5. Okay? So it still works. Now when I apply that over here, I would do something like this. I'd make a point, and then from there I would go down 6 units. 1, 2, 3, 4, 5, 6. Make a point. Make another one. 1, 2, 3, 4, 5, 6, 7, 8. Remember, we doubled all the lengths here. And then just connect the dots for the last one. Okay? So this would be a 6, 8, 10 triangle. Okay? Now from there, you want to label your vertices. And so this one, this P, would be there. It doesn't say where the Q has to go. Okay? It doesn't say right triangle Q. So Q and R can actually be interchangeable. You just want to make sure that you've got the ratio there. So the cosine of angle P, this angle here, is going to be 6 over 10. The cosine of angle P, 6 over 10, will equal 0.6. Okay? So again, not a hard problem if we know how to look at things there. All right, the next one. This is what we've been talking about over the last couple of days when we've talked about probability, okay? And I hope that you're able to kind of grasp this a little better than what you were before. So here's what we have. Francisco asks the students in the school what pets they have. He studies the events shown. Event S, the student has a cat. Okay. Event T, the student has a dog. Francisco finds that the two events are independent, meaning if they have a cat, that doesn't necessarily mean that they're going to have a dog, and vice versa. Select all the equations that must be true for events S and T. Okay. Now, remember that line that comes up there means given. So the probability that S given T. Okay. And so here's what I want you to think. What's the probability that a student has a cat given that they have a dog? Okay. Now, if they are independent of each other, the influence that they have a dog does not influence whether they're going to have a cat or not. Okay. And so as a result, what's the probability that they have a cat given that they have a dog is just the probability that they have a cat. Okay. It would be that one there. Okay. The second one would be, what's the probability that they have a cat given that they have a dog? Is that going to be the probability of the dog? And the answer is no. Remember, what's the probability that we have a cat given that we have a dog? This dog has no bearing on the cat because they're independent of each other. Okay. For the next one says this, what's the probability that you have a dog given that you have a cat? Dog given that you have a cat. Well, remember, the fact that you have a cat has no bearing on whether you have a dog or not. So again, this has nothing to do with it. Okay. The next one says, what's the probability that you have a dog given that you have a cat? Well, this has no bearing on this, so our probability has to be the dog there. Okay. Now, for the next one, when you think about independent probability, what's the probability that you have a cat or a dog? We don't multiply those when we have independent probability and we're talking about one or the other. Remember, if you remember the problem I gave on the school athletes that they can't play more than one sport during a season, and the statement was, what's the probability that a person plays basketball or is on the swim team? Well, you take those probabilities and you add them together. Okay, so that's not what they're doing there, so this is incorrect. Okay, I wouldn't use that. Now, for the last one, what's the probability that the person has a cat and a dog? Well, independent probability, and you want to know both, you're going to multiply them, and so that gives another check right there. So again, I know probability can be pretty tricky, and so my hope is that even though we covered it kind of quickly here right at the end, that you're going to be able to pick up a few points here and there based on probability. All right, let's look at the next one. Okay, this one says this, and I'm going to try to make my screen a little bit smaller again so we can see everything. I'll keep it that big to start off with. You guys have it written out there too. A teacher draws a circle. Angle RPQ and angle ROQ are as shown. The teacher asks students to select the correct claim about the relationship between angle RPQ and angle ROQ. Claim number 1 is that the measure of angle RPQ is equal to the measure of angle ROQ. Now again, you can't do this for all problems, but if you look at this, is this angle right here equal to the measure of this angle right here? And I certainly hope that you guys can just look at that and know that that's not true. Obviously, angle ROQ is a larger angle than angle RPQ. Okay, so the second claim is this: the measure of angle ROQ is twice the measure of angle RPQ, which is true. Okay, and we're going to prove that. Which claim is correct? Obviously, it's claim number 2. Justify your answer. Type your answer in the space provided. Okay, so if I were to do something like this, let me go ahead and make this smaller here. Okay, I don't know if you can see that. Maybe that's too small. Okay, so if I were to do something like this, I would say something like this. I would have to say something to the effect that angle ROQ is equal to arc RQ itself. So I would probably say something like this. Claim number 2 is correct because of the following. Okay? And then I would say something like this. Angle ROQ equals arc RQ. And I got kind of wordy when I was writing out my notes. I said the measure of the central angle is equal to the intercepted arc. I'm not sure that's necessary, okay? But at least, you know, tell the reader that you know that those are equal, okay? Build a little proof here. And maybe even want to say something like this. Because the central angle equals the arc measure. Okay? And then you'd want to say something like this. Arc RQ is, so equals, 2 times angle, maybe you can put parentheses, angle RPQ. And then I would maybe even do something like this. The inscribed angle is twice the intercepted arc measurement. Something to that effect, okay? And then by substitution, you can go ahead and take out angle or arc RQ and put in angle ROQ. So you could say angle ROQ equals twice angle RPQ by substitution. Okay? So just something to that effect that kind of lets the reader know that, hey, you know that there's a relationship between those angles and that arc, and here's what it is. Okay? So again, I hope that was, and a lot of times I think more words are better when we're trying to justify things. So, all right, let's look at the next problem. Okay? The next problem says this, and I might, well, you can see it on your paper there. It says, given triangle ABC is isosceles, point D is the midpoint of AC. And we're going to prove that angle BAC equals angle BCA. Now you guys already know that. That's the isosceles triangle theorem. Okay? And so as I read down through this, it says, I want to read every single step and make sure it's all present within the picture. And I'll be honest with you guys, you might want to draw this type of problem out on a scrap sheet of paper because just having it on the screen isn't really enough to make things click mentally, okay? So make sure you draw this out on your screen, on your paper, sorry, not on the screen, okay? So here's what we're looking at. It says triangle ABC is isosceles and D is the midpoint of AC. So we've got everything marked out so far. It then says that AD is congruent to DC. So I would go ahead and on my paper, on my scratch paper, I would put that down. We also know that BA is congruent to BC, which was already labeled, but again, make sure that's on your paper. And then it says BD exists. Now we don't do that. I mean, I think it's kind of a waste, but I'm going to put it in. BD exists, okay? From there, it says BD is congruent to BD. Now, I need to be thinking to myself, what property is that? Now, I'm going to be really upset if you guys get this one wrong because we have hit this one a ton, okay? So I'm going to take this reflexive property and move it up in there, okay? From there, we know that the triangles are going to be congruent by side, 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 side. So I'm going to take the side, side, side congruency postulate. Oh, not side angle side. Let's do side, side, side. Put it in. Okay. And then from there, how do I know that this angle BAD has to be congruent, or BAC is congruent to BCA? Well, if you look down at your options down here, corresponding parts of congruent triangles are congruent, CP, CTC. Okay. So again, not a hard problem. Hopefully, I would hope that a lot of us could get that right. I want you to draw that in though. So again, please take the time to draw those pictures out and make sure you've got everything correct. All right, the next one says this: the proof shows that opposite angles of a parallelogram are congruent. And you guys already knew that, but here's what we have. ABCD is a parallelogram with diagonal AC. And we know that angle BAD is going to have to be congruent to DCB. So we're going to prove that. So again, I'm going to walk through everything. I'm going to mark everything up in my picture so we can figure out what this little doohickey is going to have to be right here. So it says ABCD is a parallelogram with diagonal AC. Got it. I know those lines are parallel. And so again, I would draw this out on my paper. AB, CD. I know that AD is parallel to BC. So again, I would draw out on my paper. We would know that 2 is equal to 3. And we would know that 1 is equal to 4. Okay? And you know, alternate interior angles are congruent. You got that there. I would use that later on if you need it. Okay? If it ever pops up again, go back to this question. You have a chance to go back. Use questions to answer other questions if you need to. We know that 2 equals 3 and 1 equals 4. Measure of equal angles or congruent angles are equal. Not sure why they really need to do that. Didn't make you guys do it. Okay. From there, they know that angle 1 plus angle 2 equals angle 4 plus angle 2. Angle 1 plus angle 2 equals angle 4 plus angle 2. Okay. What they're talking about there is this. If I add this angle plus this angle, that would have to equal this angle plus this angle, because when you add two angles to the same angle, the two angles that you added to that same angle have to be congruent. So if it helps to think of it this way, 40 and 30, and what in 30 would have to be this one? So 40. So 70 equals 70. Okay. The next one says this: angle 1 plus angle 2 has to equal angle 4 plus angle 3. Now, I'm going to tell you right now, I want to look specifically at these two steps right here. Okay? And so as you look at those two steps, let me erase the bottom portion of that real quick. When you look at those two steps, what do we see in comparison to this step here? Okay? Well, we see angle 1, angle 2, angle 3, or angle 4, and then, oop, these guys are different. But if I look up at this step, since these guys are equal, I can take this and plug him in for this. So what are we doing when we plug something of equal value in for something else? We are substituting. Okay? All right. So again, don't get that one wrong. You've used substitution quite a bit. All right. Next one. Is it 9? Yeah, there we go. Number 9. We are going to cover this over the week leading up to your air test, which is constructions. And it's actually a very cool form of mathematics dealing with a compass and a straight edge. And so here's what the deal is. If you have, we talked earlier on this year that when you have a segment, let's say points A and B, and I find 2 points that are the same distance from that point. Okay, so this point here is the same distance from A as is from B. So C is the same distance here and here. Okay, and let's say I go down here and I find a point that's the same distance from, let's say D, from A as it is from B. Okay, doesn't even have to be the same if we don't want to. Okay, but here's what we know: any point that lies on this line that connects those two has to lie on the perpendicular bisector of that segment. Okay? We talked about that early on this year. So as a result, as we look over here, which one of these is it says this, which diagram shows only the first step of constructing the line perpendicular to AB through point P? Okay? And here's what I want you to know. When we started here, here would have been point P. Okay? And what we needed were 2 points that were the same distance from this point right here. That's the start of this. We need those 2 points, and then we can build these points here. Okay? And so how do we find those 2 points? Well, you're going to take your compass, put the pointy part here, and make an arc here, and then circle it around and make an arc there. Okay? And then using those 2 arcs, you put your pointy part here and make an arc above and below, and put the pointing part here and make an arc above and below. And when I connect them, that is a perpendicular segment to AB. Okay? So as a result, what's the first step? It's just making those marks on both sides. That right there. Okay? If you look at C, that's the final conclusion. A took it one step further, where they actually made the line, and B forgot to make the 2 points that are the same distance from P, and so that's why that won't work. Okay, and so if you're confused by this one at all, understand that we're going to cover this before your air test. All right, let's look at the next problem. Okay. Parallelogram ABCD is shown. Point E is the midpoint of segment AB, and point F is the midpoint of segment CD. Okay? Now, one of the disappointing things is when it's on the computer, you can't make these little markings out. But I would encourage you to make those markings to know that those are the same lengths. Okay? Which transformation carries the parallelogram onto itself? All right? Now, if I go ahead and do the first one, a reflection across line AC, if I go ahead and draw on that line right there, I hope you can see that if I was to reflect this across this line, remember, the distance from here to here has to be equal to the distance from here to here, okay? So, and it's got to be perpendicular. So if I draw that perpendicular, you're looking at B being somewhere over in there, and you're looking at D being somewhere over in there. So as a result, this first one is not going to be the case. It's not going to be a reflection like that. And you got to be very particular when you look at those things. For letter B, the reflection of across line segment EF. If I look here, if I reflect this point across segment EF, we're going down here, probably right about right there. For B, D will go up here. Okay, and so what you're seeing here, A would go up in here. So this would be where A prime is, this would be where D prime is, B prime would be here, and C prime would be down here. Okay, so the new parallelogram across that line would look like that. Okay, so as a result, it's not carries onto itself, meaning it becomes the same exact figure. Okay, when you read this carries onto itself, it's got to be the same exact figure. Letter C, a rotation of the figure 180 degrees clockwise about the origin. The clock goes in this direction. Okay, so as a result, if I rotate this 180 degrees, we're looking at point A being somewhere in here. Okay, 180 degrees, D will be somewhere over here, probably right in there. Okay, see, so you're going to end up with something over here like this. It doesn't map onto itself. Okay, so that leaves the last one, a rotation of 180 degrees clockwise about the center of the parallelogram. So if I draw a point on the center of the parallelogram and I rotate 180 degrees around that, here's a line. If I go 180 degrees to that, it would be that line right there. Okay, if this is the center of the parallelogram, that definitely works. A goes there, C goes there. If this is the center of the parallelogram, 180 degrees would be down here, and B would go there and D would go there. So as a result, we know that that would have to rotate and it would map back onto itself. Now it brings up an interesting reminder. Remember, the diagonals of a parallelogram bisect each other. And you see that here. These are congruent and those are congruent. Okay? All right. Looking at the next problem, let me get my paper turned over, my notes, my cheat sheets. Okay. It says this: square ABCD is transformed to create the image A prime, B prime, C prime, D prime as shown. Select all the transformations that could have been performed. A reflection across y equals x. Well, if I do that, remember the equation that we just got done doing a little while ago. There's y equals x. If I reflect B across this line, does that end up down there? And if you say yes, then we have some major issues. The reflection of B across this line would end up being right there, and D would go right there. So the very first one is absolutely not going to work. Okay? The reflection across line y equals negative 2x. Now, as I work this out, I'm going to put plus 0. All right? And I made a little note on my paper here. Rarely will you ever see something reflected across a line like this. At this level of mathematics, we're looking at y equals x and y equals negative x. It's just very hard to do. But if I graph that on negative 2 over 1 slope, okay, from the origin, negative 2 over 1, positive 2, left 1, we're looking at something like this. All right, so, that didn't work. Try again. So if I wanted to reflect this across that line right there, this is a negative 2 over 1 slope. So the perpendicular slope to that will be a positive 1/2. So if I go, that's hard to do. I can't go up 1 over 2. Up a half over 1, I'm not even there. So I'll go up a bit. Up a half over 1. Yeah, it's just, I guess the easiest way would be to draw a line perpendicular. Up 1 over 2. This line would be perpendicular to that line. Okay? And if we think about equal but on the opposite side, this is, you know, it would be up in here, like right in there. Okay? That's where A would be. If I go the other direction, down 1 over 2. Here's that line, so you're looking at, it'd probably be down in here. So I hope you can see that that's not an option either. Okay? So let's look at the next one. A rotation of 180 degrees clockwise about the origin. So if I rotate this 180 degrees clockwise, now again, clockwise goes this direction, about the origin, where's everything going to end up? Well, 180 degrees clockwise. Now notice, here's a straight line. That's 180 degrees, moving it clockwise. A would end up there. Okay? If I do 180 degrees clockwise, here's what I want you to see. When I connect B to B prime, that's 180 degrees. Okay? Through the origin, C, that's 180 degrees. Through the origin D, that's 180 degrees. It's a straight line. And so that would map onto it. Okay, so that one does work right there. A rotation of 180 degrees clockwise about the origin. For the next one, a reflection across the x-axis, then a reflection across the y-axis. Well, let's try 1 point. Reflection across the x. Boom. Reflection across the y. There's the y, so I should do this. To get to the x, it's 1. To get away from the x, it's 1. To get to the y, it's 1. To get away from the y, it's 1. Let's try C. To get to the x, it's 1, 2, 3, 4. So I've got 1, 2, 3, 4. To get to the y, it's 1, 2, 3, 4. To get away from the y, 1, 2, 3, 4. And you can continue going on around there, but what you're going to see is that those points map right back onto themselves. So this is also an option right there. Reflection across the x and then a reflection across the y. For the last one, a rotation of 270 degrees counterclockwise about the origin. Let's go ahead and, well, first of all, 270 degrees. If this is 0, 270 degrees, counterclockwise would be 90, 180, 270 right there, okay? So if I go ahead and set this up, C to the origin, and I want to go 270 degrees, I can go ahead and draw in, keep that going. Okay, there's 180, and drawing a line that'll be perpendicular to it. Okay, so if I take C and I rotate that 270 degrees, we're looking at there's 90, 180, 270. Okay, and what you see is that point does not map back onto C. Okay, and so as a result, it's just going to be the third and the fourth options there for your answer. Okay. All right. The next one. A cross-section of a right triangular prism is created by a plane cut through the point shown and is also perpendicular to the opposite base. What is the most specific name of the shape represented in the cross-section? Okay. So a cross-section, where is that? A cross-section. You guys have seen cross-sections in your biology before where they kind of cut a human in half and they split them open and you can see all the insides, different animals or maybe a flower. You've seen cross-sections. If I take a cross-section of a polyhedron, a three-dimensional shape, I'm just going to take think of a big old guillotine right here, and my blade going to come right on down, and it's going to cut through, and it's going to cut through, and I'm just going to connect those points where it comes to the other end, okay? And so as a result, what they're really asking is if I peel this shape open, what will I see on the inside? And I'm going to see a rectangle there, and so that one's going to be a rectangle. If I were to take a triangular prism, a very poorly drawn triangular prism, all right, and I were to go ahead and make a cross-section of that, splitting it down vertically, okay, would come in here, and I were to open it up, what type of shape would be shown? It'd be a triangle, okay. If I go ahead and take a golf ball and split it horizontally, what shape is shown? It's going to be a circle, okay? So just something to think about as you're looking at those type of problems there. Okay, cross-section's not meant to be hard, you just have to be able to visualize them. All right. Getting to this one, we've covered this now, and I let you have the formula up on the board, but I noticed on your formula sheet, you're not going to be given the formula for a circle. And so it's very important that you have that formula memorized. If you don't have this memorized, x minus h squared plus y minus k squared is equal to the radius squared, you'll want to have that memorized because it's too simple of a problem to get wrong. It really is. And so remember the center is going to be at hk. So what they're talking about, write the equation for the circle, okay? Well, if I look up here, I know my center is at 1, 1. And my radius is at, I can go any direction here, 1, 2, 3, 4. Okay, so the radius is 4. So when I plug this in, what I should see is this, x minus 1 squared plus y minus 1 squared is equal to, does it matter how they write it? 4 squared, okay? And so as you work this out, I actually prefer the 16, but I think when I looked at the key on the test, they said leave it as 4 squared. I really don't think they should count you off either way. It'll be interesting. Yeah, I would go ahead and square it, but here's what you have. if I'm going to type this in, and you'll probably want to practice this, where are the parentheses at? Do they show parentheses down here? Do they even have an x? Tan, arc cosine. There you go, parentheses. So do we have an x? Yep, x minus 1. Is that minus? Yep, good, 1. And then we're going to go outside of it. Squared. Looks like, ooh, I may have to do this. Yeah, squared. And then you notice I tapped away from it. If you're going to be on next to it, tap away from it, it'll go down. Okay. And then plus, and then a parentheses, y minus 1 squared. Nope. Equals. Okay. Equals. Did you notice that it could go down? I don't want to do that. So be very careful there as you type. Oh, that's not good. How do I go back? Back. Oh, no. Go back. Back. No. Go back. How do I delete? Delete. There you go. It's the X sign. So I might have to play around with that a little bit. I want it right there. Why does it do that? Well, I'm just going to leave it like that. 16. They better not count you off for that. That's just weird. So, and so that's what I would do. That's the equation. They shouldn't be too picky on that. Stupid computers. Anyways, all right, let's look at the next one. All right, the next one. Oh, did I skip one? I think I skipped 12. All right, you can see this. I must have double-clicked it on accident. Okay. Now, there may be faster ways to do this problem here. So as I show you this, try to be thinking of a quicker way. I didn't know. I know one way that I know, but maybe there's a faster way. And if you know it, let me know, and we'll spread the word. So, the planets in our solar system can be modeled using spheres. The diameters of Jupiter and Saturn are shown in the diagram. The volume of Saturn is 59.9% the volume of Jupiter. What is Saturn's diameter, d, in kilometers? Round your answer to the nearest thousandth. Okay? So, and we already know the diameter of that one. And so the reason why they're giving the volume, in terms of the volume, is they want to know if you can convert from volume to a length. Okay? And so we talked earlier on this year that if you have a similar figures, okay, the similarity ratio could be identified as A to B. Okay, so notice they're both spheres, so they have to be similar. Okay, spheres, circles, all of them are always similar because they got the same structure, just one can be bigger than the other. Okay. Now the area ratio, if you remember us talking about the area ratio, that was the square of each of these. Okay? And the volume ratio was the cube, is the cube of those. Okay? And so here's what I need you to think through. If they give us the diameter, that is a component of the similarity ratio. This right here. Oh, that right there. Okay? But unfortunately, they gave us the what was it, the percentage of the volume. So what we have to do is we have to take this volume ratio and convert it back to the similarity ratio in order to figure out what the diameter is going to be of the smaller structure. Okay? And so knowing this, you could go ahead and say the volume of Saturn and this would be in percent, so I should probably do this, 0.599 to the volume of Jupiter. Okay? and this is your volume ratio. This is what we're at right now, okay? In order to go from here to here, let's first of all talk about how to go from here to here. How do I undo these squares to go back to that point right there? Well, I'm going to square root, right? To undo the squares, we square root. You guys are really good at that. You know that really well. Well, let's go down to this one. How do I undo a cube to go from here back to here? Well, you're going to cube root. Now, what does the cube root looks like? Well, the cube root looks like this, okay? And so you need to find that somewhere on your calculator. I will tell you that since most of you have the larger calculators, I'll find it here real quick. The cube root button, you can go to the math button and down 4 spaces and you can see the cube root button, okay? And so what we're going to do is we're going to cube root both of these to get it into the similarity ratio form. So it will be this, the cube root of 0.599 to the cube root of 1. Okay. Now what's nice is the cube root says what number times itself again is equal to 1. Well, what's 1 times 1 times 1? It's just 1. Okay. So we basically have this ratio here, the cube root of 0.599 over 1, or the cube root of 1, either way it's the same, is equal to the diameter of Saturn, we'll say d, over the diameter of Jupiter, 142,984 kilometers. Okay? And so if you just cross multiply here, right here, you've got your answer. Okay? So as I plug this into my calculator, here's how I would plug it in. I always take the bigger number first because there could be some parentheses issues here. And so it would be 142,984 times, and that would be the cube root of 0.599. Okay? And so when you do that, you're going to end up getting, let me see here, 120, now, oh, this is also important, nearest thousandths. Okay, don't miss a problem because of the stupid technicality right here. Thousandths. If I go after my decimal point, the first one is the tenths. The next one is the hundredths. Okay. And then you have your thousandths place. Terrible. All right, thousandths place. And so it's got to be 3 places after the decimal. So if you work that out, what you should end up having, and I actually want to use the computer part just to make sure there's nothing that I need to change, is going to be 120,000. What's the next part? 530 point, you got a decimal point? Yep. And that would be 340. Okay? And so just try to make sure that we understand how to use the technology along with what we've already had. All right, let's go to the next one. We've already done that one. Oh, too far. All right, let me look at this one real quickly here. Gotta get my papers. Okay. The graph of line M is shown. What is the equation of a line perpendicular to line M that passes through 3, 2? Okay. Well, here's another formula that you're going to have to memorize. Didn't know this wasn't on your formula sheet, but not only do you want to know the slope-intercept form, but you also want to know the point slope form. Okay? Now, point slope form says we need a point and we need a slope. Okay? So the point that we're going to be looking at is this one right here. Okay? So y minus y sub 1 is equal to the slope, parentheses x minus x sub 1. That's your point slope form. Okay? Now, remember, your perpendicular slopes have to be the opposite reciprocals. So perpendicular slope equal opposite reciprocals. Okay? So if I give you the slope of a line which is 5 over 2, the perpendicular slope is going to be negative 2 over 5. Remember studying that back in chapter 3, 4, something like that? If I give you the slope is just 1, it's going to be negative 1. If I give you the slope is negative 2 over 7, the opposite reciprocal is going to be positive 7 over 2. Okay, so make sure you understand that relationship with the perpendicular slope. So if I were to do this, that passes through the point 3, 2. There's 3, 2. Okay, and notice the slope here, 1, 2, 3, 4, 5, positive, 1, 2, negative 2. Okay, so our line right now has a slope of 5 over negative 2. Now if I convert that, this is going to be a positive 2 over 5. Okay? Now what you could do from this point here, if this is our point that we're going to pass through, you could just go ahead and graph out 2 over 5. 2, 1, 2, 3, 4, 5. There would be 1 point. I go the other direction. 1, 2, 1, 2, 3, 4, 5. Okay. Now the problem is this. We're not crossing right at a good point right there. So graphing it probably wouldn't be a good idea, but plugging in the equation over here is. So if I plug in my y value, which comes from over there, my point, 3, 2, 2 is the y value, is equal to the slope. Remember the slope we found is going to be positive 2 over 5. And then we have equals x minus the x value, which is 3. Now I'm going to show you a couple of different things that you could do here to finalize your answer. According to the scoring guide, you can leave it just like this. Notice what we're doing. We're just adding 2 to both sides. Okay, you can leave it like that. That's okay with them. How I taught you to do it was to go ahead and distribute the 2/5. Okay, so that would have given you this, 2/5 x, and then that would be negative 6 over 5, so negative 1 and 1/5. And then I told you to add the 2, so that gives you a positive 4/5. Okay, yeah. Now the only problem with doing that, there's a lot more math involved, and on the standardized tests, sometimes it's just best to get the answer right and get out of there. So I don't care how you want to get it, put down your answer. According to the scoring guide, they say that you're going to, they'll give you credit for either one. So when I look at this, if I'm going to go ahead and answer this, is it going to go down? Okay. Y equals, they already have the y equals there for you, so you don't have to type that in again. I'm going to go ahead and do something like this. 2/5 x, backspace, parentheses, x minus 3, and then plus 2. Okay, again, you can go ahead and do it the other way as well because you may be more used to doing it that way, but either way is fine with me. Okay? All right, let's take a look at the next one. Okay, number 16. Line segment AC has endpoints at A and C. Point B is on line segment AC and is located at point 2, negative 3. What is the ratio of AB to AC? Okay, again, you have to draw this out, guys. It's very hard to visualize this unless you can see everything. So here's what I'm going to do. Okay, we have 5, negative 1. 1, 2, 3, 4, 5, negative 1. Okay, so there's point C. Point A is at negative 1, negative 3.5. 2, 3, 4. So we're looking right in there. Okay, that's point A. Now the question is, point B is on the segment AC and is located at 0.2, negative 3. So 0.2, negative 3. We're down in there. Okay, so that's point B. And we want to know the ratio of AB to AC. Now, you can do several different things here. You could go ahead and figure out the length of AC and figure out the length of AB. Okay, that's completely acceptable. Again, by doing the Pythagorean theorem, maybe a little more work than you have to. I know that this length, if this is at negative 3.5 and this is at negative 3, then this is going to be at 0.5, that length there. And this length here is going to be at, let me see here, we're at 0.2 and negative 1, so 1.2. So you could use that. The bigger length, using the Pythagorean theorem, we're down here at 3 and we're going up to 1. So we're at length of, oh no, this is 3.5. So 1, 2.5. Okay. And this length right here is a length of 5 plus 1, so we're at length 6. Now, what's interesting about this, you don't have to actually figure out the distances here, okay? Even though you think you do. So AB, oh, maybe I do. Hold on. I almost told you wrong. AB to BC. Let's see here. Oh, okay. Well, give me 1 second here. I almost led you astray on this. Okay. Let me actually erase some of this so it's a little clearer for us. I was thinking when they first introduced it, it was AB to AC, but they want to know AB to BC. Okay. And that does change the problem a bit. Okay. So if I go ahead and fill this out, going from B, there we go, going from B to C, up and then over, okay? Now, this length right here is going to be over, let me think here, 4.8 units. So 1, 2, 3, 4, plus the 0.8, because remember this is at 0.2. 4.8, okay? This length right here, I'm down here at negative 3. Yeah, negative 3. So this is just up 2. Okay? So again, like I said, you can use the Pythagorean theorem there and figure out those two lengths. But these two shapes, they are parallel to each other. Okay? I know that the corresponding angles here are congruent. I know that the corresponding angles here are congruent. And so the two shapes are going to be similar to each other. I think I said parallel a moment ago. They are similar to each other by angle, angle. Again, we've got angle and angle. Okay? So as a result, if they're similar, then their side lengths have to be proportional. So you really only need to do this. 0.5 is to 2. And figure out what that is. And this length here will have to be the same length as that one. You could do 1.2 is to 4.8. And if you figure out that, then you're good. Now, I like this one better because I know if I go ahead and multiply this by 2, multiplying 0.5 by 2, you get 1. Multiply 2 by 2, you get 4. But if you would prefer this one over here, if you multiply this by 5, you get 6. Multiply this by 5, 20 and 24. So you end up with 1/4 as well. Okay? So yeah, again, the ratio, what is the ratio of AB to BC? I would just put in 1 to 4. Okay? So, hope that made sense. The next one we have is this. Triangle ABC has vertices at the following. What is the perimeter of triangle ABC rounded in the nearest tenths place? Okay? So what I'm going to do here is, again, on my scratch paper, I'm going to go ahead and label all these points here. So negative 4, 0. place my point. I have one at negative 1, 6. Place my point. Okay. And I have one at 3, negative 1. Okay. So this right here, we have to find the perimeter of. Now how would I do that? Again, I use my Pythagorean theorem. I just go ahead and finish off the right triangles here. Okay, so we will be over, let's see here, this is at 1. So 1, 2, 3. And this would be up 1, 2, 3, 4, 5, 6. Okay, so I would do, let's say this is AB. 3 squared plus 6 squared equals AB squared. Okay, so 9 plus 36 is 45. We're looking at the square root of 45 for the length of AB. Okay. BC, if I'm going to go from here up to here, okay, so this would be 1, 2, 3, 4, 5, 6, 7. And this would be 1, 2, 3, 4. So BC would be 7 squared plus 4 squared is equal to BC squared. Okay. From there we have 49 plus 16, which would be 65. And the square root of 65 will be BC. Okay. And then for AC, this length is 1. And then this length is 1, 2, 3, 4, 5, 6, 7. So you have 1 squared plus 7 squared is equal to AC squared. Okay. So this will be the square root of 50 is AC. Okay. Now, for this last answer, what is the perimeter round to the nearest tenths? Make sure that when you do this, square root of 45, that square root stops. Square root of 65, that square root stops. And the square root of 50. If any of you are using the smaller calculators, make sure you close off your parentheses there. All right? And so in the end, when we work this out, you should get 21.8 as your final answer, that perimeter of that. Okay? All right, number 18. Let's go on to number 18. We're getting to a volume formula now. Okay, Allison designs a fancy boxes to fill with chocolates. That sounds good. The boxes are in the shape of the right square pyramid as shown below. Now, when it says right square pyramid, that just means that where these vertices come together, it's directly over the center of the base there. Where 8y represents the length of one side of the base of the pyramid, and 5y represents the height of one triangular face of the pyramid. The large size box must be designed to have a volume of 1,000 cubic centimeters. Create an equation that can be used to calculate the length of the base and the height of the triangular face of the box. Enter your equation in the first response box. Okay. So let's see here. Okay. So what I need you to picture here before we get going is this square pyramid. So if I could draw the square pyramid, it would look something like this. And I'm not going to do it justice with this horribly inaccurate board. Okay? But what we're looking at here is this. They're giving us 5y, the height of a triangle. So I would do that right there. Okay? That's the height of the triangle. And they're giving us 8y, so this is 5y here. And they're giving us 8y is this length of this side right here. Okay? And what we have to find is the height of the actual pyramid, because what we know is that the volume of a pyramid is 1/3 the base area times the height. Okay? So if I go ahead and do this, drop this down here, bring that over, okay? What you should see, and this is a shame that we haven't covered volume yet, but this length right here, I know it's not parallel, it should be more like that, okay? this length right here is half of this length right here. So that is going to be 4y right there. Okay? And so now we need to figure out what that length is going to be, because that's our height of our pyramid. Well, if I redraw this right triangle here, here's what you have. And again, I'm not drawing it to proportion, but there's the 4y, there's the 5y. Anybody know what that length should be? It should be 3y. Okay, it's the Pythagorean triple 3, 4, 5 with just the y next to it. And so what I'm going to do here for my equation, the volume is going to be 1/3 the base area, which you can do 8y squared, or you can do just 8y times 8y, it's the same thing, times 3y. Okay? And so, I guess, well, to finish that off, since it has to equal 1,000 cubic centimeters, you'd probably want to put the 1,000 in right there. Okay? No volume needed, just put the volume in itself. Okay? Then from there, we want to find the length of the base and the height of the triangular face. So what I would probably do, I would probably simplify this equation as much as I could and then solve for y. So I know 1/3 of 3 is just 1, so those are gone. And if I take 8y squared, that's actually 64y squared. And we're going to multiply that by y, this y right here. Okay? And so when I work this out, y times y is y cubed. So my equation will actually look like this. 1,000 is equal to 64y cubed. Okay? Now how do I go about and solving it from that point? Well, I'm first going to divide by 64 on both sides. So I end up with this. Let's see. 15.625 is equal to y cubed. Okay? Now again, remember we talked about a couple minutes ago. In order to undo that cube, you need to cube root. And so in the end, the y value will be 2.5 units. Okay? Now, the length of the base isn't 2.5 centimeters. The length of the base is going to be 8 times that. So if we do 8 times 2.5, that will give you 16, that'll give you 20. So that's where the 20 has to go. Okay? And again, this is where the 1,000 equals 1/3 8y squared times 3y will have to go. Okay? Now the last part is the height of the triangular face, which is the 5y. So if I take the 5 and multiply that by the 2.5, 10, 12 and a half, okay, that would be this length right here. Okay? So again, just some things there to think about. And I know volume isn't going to be the easiest because we haven't talked about it a whole lot. So, all right, let's take a look at the next one. Okay. Kyle performs a transformation on a triangle. The resulting triangle is similar but not congruent to the original triangle. Which transformation did Kyle perform on the triangle? Well, let's start at the very bottom here. A translation is just where we move the figure so many units right, so many units up. So the result of a translation is always the same exact figure. It's congruent. Okay. If I rotate something, okay, if I were to rotate myself around, I haven't changed my size in any way. Okay. I've just moved from facing one direction to facing another direction. And so, like the translation, the figure remains congruent. Okay? Reflection. I know that some mirrors can reflect you in distorted ways, but a normal reflection gives you an accurate depiction of what you are. Okay? And the same thing is true within geometry. When you reflect an object, it's going to be congruent to itself. So the dilation is where we get bigger and smaller, and that'll be your answer there. Okay? The next one, triangle ABC has vertices at A, B, and C. It's dilated by a scale factor of 1/2 about the origin to create triangle A prime, B prime, C prime. What's the length in units of side B prime, C prime? Okay. Now, this is where it would become very helpful to have some sort of graph paper, and I need to actually make a note of that to make sure Mrs. Hurd gives us graph paper. Just something with some graphs on it. And so here's what we're going to do. Triangle ABC, we're going to graph that out. So let me take a look at this. Okay. I'm going to do that actually over here. Okay. And so what we know right now is that A is at 1, 1. I'm going to try to get this kind of big so that we can see everything. All right. So A is at 1, 1. B is at 2.5. Oh, 2.5 comma 3. So we're up in here. And C is going to be at 0, -3. So C is down there, and yeah, I didn't know if my board was even going to work that well. Okay, there's C. Okay. And what we want to do what we want to do is figure out, it is dilated by a scale factor of 1/2 about the origin. So it's really simple, and all we have to dilate actually is BC. So if I were to take the distance from B to the origin, okay, that's up and over, up 3 and over 2.5, okay? Whatever that distance is, okay, I'm going to go halfway up and halfway over. So up halfway up would be 1.5, and up halfway over is going to be, now again, this is 2.5, so 1 1/4. Actually, it should be on that line right there if I drew it straight enough. So this point right here is over 1 1/4, up 1.5. Okay. For C, since I'm dilating at half the distance, this is a lot easier. This is up 3, so I'm going to go up half of that. Okay. And so as a result, I need to know, and again, this is 0, -1.5. I need to know this length right here, from B prime to C prime. That's what we're actually looking for, right? What is the length in units of B prime to C prime? So in order to figure that out, I would go ahead and do the Pythagorean theorem again. Now, you can use your distance formula. Okay, you can do your distance formula. You don't have to do the Pythagorean theorem, but I think the Pythagorean theorem is easy enough to do. If I just do this, okay, 1.5 to there, maybe I should use a different color. Try this one. 1.5 to there, and then this is up another 1.5. So this is just up 3, okay? And I'm going to go over, well, we already knew that, 1.25, okay? And so from there, if I work this out, we have this, 3 squared plus 1.25 squared will equal B prime to C prime squared. Okay? So if you work all this out, 9 plus 1.5625 is going to give you 10.5625, and we're going to square root that. Okay? And so in the end, it doesn't say, what is the length of that side in units? Well, if you square root this, you actually get a nice easy number, 3.25, okay? And so that's how I would do it there, okay? But again, remember, the distance, if we're dilating something, back to the point of dilation has to increase or decrease by that size. So the rise and the run, having it makes it half the size, okay? All right, let's move on. We've got number 21 now, okay? And here's what we have. We have another little proof here that we have to fill in the information on. And so it says this. We have these lines that are parallel. So let me just read the beginning. Triangle PQR is shown where ST is parallel to RQ. Marta wants to prove that SR over PS is equal to TQ over PT. Now, if you remember earlier this year, we proved this one in class, okay? And so place the statements or reason each blank to complete Marta's proof. So the lines are parallel, and that's given. That's good. We know that PST and angle R and PTS and angle Q are congruent. Now again, please draw this out in your paper. PST and R are congruent, and PTS and angle Q are congruent. Okay? So how do we know that those triangles are similar? Well, all I'm going to do is put down the angle-angle similarity. Okay? All right. Remember how to prove triangles similar. Triangles similar are going to be angle-angle, side-angle-side, or side-side-side. Okay? Triangles congruent, if you remember, are going to be side-side-side, side-angle-side, angle-side-angle, angle-angle-side, and hypotenuse leg. Okay, so don't forget those ways. So if I take a look here, we need to go from there. So how do I set up the proportion that would lead me to this proportion down here? Okay, so as I read the proof, I'm looking at this one, and I'm looking at this, and I'm looking at what's going to happen here, because whenever I see substitution, it usually includes the first couple of steps after that. So as I look here at similar triangles, we know that their side lengths are proportional. And if I draw the two triangles separate, we have PST and we have PRQ. Okay? So what do I know? Well, I know that PR and PS are going to be proportional, and I know that PQ and PT are going to be proportional. So as I look at this, I see this proportion right here, and I'm going to, get back in there, you goof. Come on up there. There you go. Okay? And how do I know that that's going to be able to take place? Well, if you look down here, right here, corresponding sides of similar triangles are proportional. We didn't state, well, yeah, we did. We talked about the two characteristics of similar polygons. The sides are proportional and the angles are congruent. And so while I didn't have you stated exactly like that, we did go over that before. So, yeah, walk through that proof. Make sure you know every little detail as you work it out. All right, the next one, we're looking at number 22. I've got to be getting close to being done. My throat's killing me. All right, it says this. A map of Jane's town with her home and workplace is shown. Jane wants to determine the shortest route from her home to her workplace. She walks only on the sidewalks indicated by the dotted lines on the map. What is the distance of the shortest route to the nearest whole block? Okay. Jane wants to determine the shortest route from her home to her workplace. Okay. I am just rereading this, making sure I've got this down. Okay. Now, obviously the shortest distance is going to have the straightest path. And so I guess the only question I would have is it going to be this distance here, or is it going to be this distance here? Okay. And so my thinking is this one has the straightest distance to that point, because the straightest, what's closest to this line, I would assume would be this one right here. But let's wait and see. So I know that this length right here can be calculated by doing the Pythagorean theorem again. 1, 2, 3, 1, 2, 3, 4, 5, 6. So 3, 6, and I can go ahead and figure out this length here. 9 plus 36 is going to be 45, so the square root of 45 will be that length right there. Okay? And then we've got 1, and we've got this length right here. So this would be 2 by 1, 2, 3. So I need to put a 1 right there, actually 2. I'll put a 2 right there. Okay, so 2 by 3. So 4 plus 9 is 13. The square root of 13 will give me that length. And then I can count 1, 2, 3 right there. Okay, so you can go ahead and add those up, and we can check that. The other one that we could do is obviously this one right here. Okay, to see how that works out. And if we do that, this length here is actually, let me clear this off, make that bigger. Okay, this length here is going to be 2, 1, 2, 3, 4 by 4. So if we do 2 squared plus 4 squared, that'd be 4 plus 16, the square root of 20. Okay. And if we just count this, 1, 2, 3, 4, 5, 6, 7. So 7 and 1, 2, 3, 4, 5, 6, and 6. Add those together and add those together. We should be able to figure out the shortest distance there. Okay. So if I look at the first one, 2, clear that, 2 plus the square root of 45 plus the square root of 13, oh, not 12, 13, plus 3, that'll equal 15.3, okay? And if we do, nearest whole block would be 15. If we do the other one, 7 plus the square root of 20 plus 6, that's going to equal 17, almost 17 and a half. So I'm going to put down that distance is going to be 15 units, 15 blocks from home to our workplace. Okay? All right, let's keep moving. Okay, number 23. Okay. An equation is shown where 0 is less than x, which is less than 90, and 0 is less than y, which is less than 90. Okay, so basically x and y are both between 90. The cosine of x is equal to the sine of y. Create an expression for x in terms of y. Okay. Well, in order to do this, let me go ahead and draw out a picture here. Because, again, this isn't a hard problem if we know what we're actually looking at. So let's say I have x here and y here, okay? And so, let's see here. Yeah. So this would be the adjacent side if I'm looking at x. This would be the opposite side when looking at x. And this would be your hypotenuse, again, when looking at x. And so if I want to take the cosine of x, that ratio has to equal the sine of y. The only time those ratios are going to be equal, okay, the adjacent over hypotenuse is when they are the opposite of each other, okay? Within the right triangle, they have to be the opposite in order for those to be equal. And so what is the relationship with x and y? Well, the relationship is if I know what x is, let's say it's 20 degrees, How do I find y? It's just going to be 90 minus that, okay? So that's what we're going to fill in there. X and y always have to be the complements of each other in order for them, the two functions, the sine of x and the cosine of x, to be y, or to be equal, sorry. Okay? All right. Looking at the next problem. Let's see here. Two events are independent. Probability of A equals 30% or 0.3. Probability of A and B equals 24% or 0.24. What's the probability of B? Now remember, independent events, when it's A and B, are going to be the probability of A times the probability of B. Okay? You've seen that quite a bit over the last couple of days, I hope. And so if I go ahead and put this down, the probability of A and B, 0.24, is equal to the probability of A, 0.3, times the probability of B. Oh, there's my B probability. Okay? So how do I get, let me rewrite that so it's better. 0.24 equals 0.3 times the probability of B. That's better. Okay? So the question then is, how do I get probability of B by itself? Well, you're just going to divide by 0.3, and so you end up with the probability of B being, was it 80%? Okay, 0.8 or 80%. So, yeah, don't forget independent events, when it's A and B, are going to be multiplied together. Okay? All right, the next one. A total of 200 people attend a party, as shown in the table. A person is selected at random to win a prize. Probability of selecting a female is 0.6. Probability of selecting a child, given the person is female, is 0.25. The probability of selecting a male, given the person is a child, is 0.4. Complete the two-way table to show the number of adults, children, and males, females who attended the party. Okay? Well, if we look here, if I go ahead and take, let's see here, the very first one, the probability of selecting a female is 60%. That one really doesn't have anything to do with the whole problem. We get more information from the next two sentences. The probability of selecting a child, given the person is female, that one tells us actually more. So 0.25. Okay? Now, where does this come from? Well, remember, the fact that it's given that they're female is what this is over. So this is over 120. Okay? And the question is, how many of them are the children, given that they're female? So this would be children. If I go ahead and multiply both sides by 120, you're going to end up getting 30 for x. Okay? And that's the number of children here. Now that's really helpful. You really don't have to do anything else beyond that. Because if I know that, then what plus 30 is equal to 50? 20. What plus 30 is equal to 120? 90. What plus 20 is equal to 80? It'd be 60. 60 and 90 make 150. 90 and 30 make 120. 60 and 20 make 80. It all works out. Okay. You could have also come at it from the second answer's perspective, the second sentence, where it says the probability of selecting a male given the person is a child. Okay. And that was 40%. Well, if the person is a child, we know that that is 50 people. And so to figure out what x is going to be, if you go ahead and multiply 50 times 0.4, you're going to get 20. And that's what we see right there. What's the probability of a person being a male if they're a child? Okay. So 0.4, 20 out of 50. Okay. All right. Let's keep moving. 26. Sam is picking fruit from a basket that contains many different kinds of fruit. Which set of events is independent? Well, remember, what independent means is that what happens in one event has no bearing on what happens in the next event. So if he picks a kiwi and eats it, does that basket still have the same probability of picking another kiwi or an apple? No, because we're one less fruit. Okay. So anything that eats it, okay, or gets rid of, has to be a dependent event. Okay. Eats it, gets rid of it. So as a result, the answer is going to be letter D. He picks a kiwi, puts it back. He picks an apple and puts it back. Whatever happened in the first event had no bearing on what was going to happen in the second event. And that's why D is your answer. Okay? All right, the next one. Now this one, I'm going to show you how I solved it, and there may be a faster way to do it. I'd be interested in hearing what you have to say. So, in this one it says this. The probability of flipping a fair coin and heads landing face up is 50%, which is, we know that. The probability of rolling a fair number cube with sides numbered 1 through 6 and an odd number landing face up is also 50%. Simple enough. What's the probability of flipping a heads or rolling an odd number? Okay. So we want probability of heads or odd number. Okay, and I just found the easiest to do this problem by listing the 6 sides and then going off of that. When I say going off of that, what I'm saying is I'm looking at flipping of the coin and seeing, what the outcomes could be. So if it lands with a 1, it can be a heads or tail on the flip of the coin. Okay. So what's the probability of getting heads? Well, 1, 2, 3, 4, 5, 6. Okay. So right now we have 6. What's the probability of getting an odd number? Well, this is a 1 and a head. Okay, so we've already, make sure, yeah, we've already got that one. But this is a 1 and a tail, so that also works. Okay, this is a 2 and a tail, that doesn't work. This is a 2 and a head, we've already counted that one. This is a 3 and a tail, that one works. This is a 3 and a head, we've already counted that one. 4 and a tail doesn't work. 4 and a head does. We've already counted it. 5 and a tail, that one works because it's got the odd number. 5 and a head, we've already counted it. 6 and a tail doesn't work. 6 and a head, we've already counted it. So originally we had 6. If I counted up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can get rid of this 6 and make it 9. Out of the total possible outcomes, which if we look here, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 9 out of 12, which is 75%. So you could put 3/4 here. You could put 0.75. I don't think it has a percent there. It's got to be one of those two. Okay? All right. And here we come. Finally, the last problem. All right? Looking at your last problem on the review, here's what you have. Okay? A translation is applied to triangle PQR to create triangle P prime, Q prime, and R prime. So we've moved it in some way. Let the statement XY to AB describe the translation. So this is the original. This would be triangle PQR. And this is the new one, which would be triangle P prime, Q prime, R prime. So create an equation for A in terms of X and for B in terms of Y that would be used to describe the translation. So you're going to pick a point out here. You can pick any of these 3 points to go to any of those 3 points. So if I go over and up, I'm going to go back 1, 2, 3, 4. Now back would be negative. So the X is going negative. I'm going to go back 4 units. And the Y is going to go up 3. And so in the end, left 4, up 3 gives you your new point. And you can continue, like I said, doing it with all of these. 1, 2, 3, 4. 1, 2, 3. Get the same spot. So that's how you would want to answer that last one. I realize that's been a long time. I've been working on it. I hope that my video saves it all. And you guys are able to look at this. I hope that you have a better understanding of what you're going to be going into with the air test. As I said before, it's not an easy test, but I'm confident that you guys are going to do well. And I'm excited to see your scores next fall. So have a great day, great night, and I'll look forward to seeing you when I see you. Good night.